So now that we're comfortable with the idea of having a demand curve and a supply curve, and knowing that the intersection of the two of them represents our equilibrium point, what we're going to look at is area between two curves, and we're going to be using that to find consumer and producer surpluses. Okay, so in order to understand what the consumer surplus is first, what we're going to do is consider what happens once we have figured out our equilibrium price. So here, if we can assume that this is our equilibrium price, maybe again it's going to be $1.20, then what we want to look at is the situation. If I were somebody over here, so if I'm looking at this good, then I ended up paying $1.20 for the item, but really I would have paid maybe $2.25. So I end up actually saving some money. Okay, even this person right here, this person would have been willing to spend $1.75, but instead they only ended up spending $1.20. So really what we're going to look at is the area between these two curves. Specifically, we want to look at the area between the demand curve and the equilibrium price. And if I can find the area of this region, this area is going to represent the amount of money that the consumers will have saved if you consider what they would have paid for the good and what they actually ended up paying. Okay, so this area, this is what we're going to be referring to as consumer surplus. Okay, if on the other hand we look at what happens underneath this equilibrium price, if I have a good that was sold here, then what we have is a producer who was willing to sell the item for maybe 55, 60 cents, but they ended up actually selling it for $1.20. And so this is good for the producers. What they ended up getting was more money than they had anticipated. And if you actually do the integral and find this area underneath the equilibrium price and above the supply curve, that region there is going to represent the producer's surplus. Okay, that's essentially the amount of money that the producers have made when they would have been willing to sell the good for a lower price. So what we're going to look at now is going to be sort of a formal definition of these two. Okay, let's take a look at consumer's surplus and producer's surplus. So here we're going to focus first on consumer's surplus, and this is going to be the difference between the price the consumers paid and the price that they would have been willing to pay. So in the last section, when we look at the graph, what we end up getting for the consumer surplus is the area of this region right there. Okay, so this is going to be the consumer surplus. Now, how do we actually go and calculate this? Well, the consumer surplus as an integral, as area between two curves, we could do the integral, and what we're going to do is the upper curve minus the lower curve, the upper curve being the demand curve, and the lower curve simply being this constant, which is the equilibrium price. So it's going to be the demand curve minus the equilibrium price, so it's going to be minus P0, and we're going to integrate with respect, not to x, actually, we're going to integrate with respect to q. Okay, that's going to be this axis. And so now we want to look at what the smallest value of q is going to be. That's going to be 0. And what is the largest value of q? Well, that's going to be this value right there. That's going to be the equilibrium quantity Q0. So this is going to be the formula that we use to find consumer surplus. You are integrating your demand curve minus your equilibrium price, and you are going to integrate the both of them from 0 until you get to your equilibrium quantity. Now we're going to have a look at producer surplus, and producer surplus is going to be the difference between the price that the producer actually sells for and the price that they would have been willing to sell for. So if you were to add up all of this value, then really you're looking at adding up all of the area underneath the equilibrium price, but above the actual supply curve. Okay, so that's going to be the area of this region right there. That's our producer surplus. And so if we go back now and set up an integral to represent that, what you end up getting is the area starting again at 0 and going until the equilibrium quantity. We're going to be integrating the upper curve, which is constant, the upper curve, which is going to be our equilibrium price, minus the lower curve, and the lower curve is just going to be our supply curve. So it's going to be equilibrium price minus the supply curve, and we integrate with respect to Q. This integral right there, that's going to always represent for us producer's surplus. So now let's actually take a look at doing an example, finding consumer surplus, finding producer surplus. Here in the first example, we'll be looking at just finding consumer surplus, and we are given a demand equation right here, and we are given an equilibrium price of $500. So we know that our consumer surplus, we're always going to calculate it in the same way. We can do the integral from 0 up until the equilibrium quantity, and we will be doing an integral of the area between our demand function and the equilibrium price. So fine. Here we know our equilibrium price is $500. However, one thing that we are missing is this right here. We need to know what our equilibrium quantity is so that we can know what the upper limit of integration is going to be. So that will be the first thing that we start off with. Let's find the equilibrium quantity. And how do we do that? Well, we know for our demand curve, it's going to need to be equal to 500. So really what that means is we end up with 800 minus 20q minus q squared being equal to 500. Let's bring everything on the left over to the right hand side. All we have here is a quadratic, so we can just factor it at that point. We end up with q squared plus 20q minus 300 is equal to 0. So 0 is going to be equal to, if we factor this using product sum factoring, what do we get? So here, this should be 300. So we want two numbers that have a product of 300, or rather negative 300 and a sum of positive 20. So we can look at here plus 30 and minus 10. And that's going to give us that either q is going to be equal to minus 30 or it's going to be equal to positive 10. So it's odd we end up with two values of q here. However, that's not an issue. Remember that q is the quantity of goods produced, and so q is not going to be negative. What we end up with for equilibrium quantity is 10 units. So our equilibrium quantity is 10 units, equilibrium price was 500. Now we have everything we need. We can plug it into our consumer surplus integral, and we get here consumer surplus is going to be integral from 0 to 10. We're going to be integrating our demand function, which was 800 minus 20q minus q squared, and we subtract from that the equilibrium price, which was 500, and then we're going to be integrating. So here, let's just actually do FDC2. 800 minus 500 is going to give us 300, and we look at the antiderivative with respect to q, that will be 300q. Minus, we have here 10q squared is the antiderivative of this, and we have minus 1/3 q to the power of 3 will be the antiderivative of q squared, and we want to evaluate all of this from 0 to 10. So let's see what we get. We plug everything in, doing FDC2. We get 300 multiplied by 10 minus 10 times 10 squared minus 1/3 times 10 to the power of 3, and we're going to subtract what we get when we plug in 0, but when we plug in 0, everything is just going to be 0. So really, what we end up getting here, if we add all of these up, it's going to be $1,666.67. And that right there, that is the consumer's surplus. In the next example, we're going to take a look at the producer surplus. This time we're looking to find producer surplus, and we are given two things. One is the demand equation, and the second one here is the supply equation. So we can go back to our formula for producer surplus, and we know that producer surplus is going to be an integral from 0 up until the equilibrium quantity. We're doing now the area underneath the equilibrium price, so it's going to be the price itself minus the supply. So that's the integral we're looking at, and we realize as soon as we set it up that we're missing two things. Okay, we need to know what's going to be here, the equilibrium quantity, and what's going to be here, the equilibrium price. And the only way to find that is to set these two things equal to each other. We want to know when the supply and demand will actually line up. So here, let's find equilibrium quantity using when our demand is equal to supply. So let's set up that equation and solve it. On the left-hand side, we have our demand equation, which is going to be 12,000 minus Q squared. On the right-hand side, we have Q squared minus 50Q minus 3,000. So here, let's again just bring everything over to one side. We have a quadratic. So we'll have 0 on the left. On the right, we'll have 2Q squared minus 50Q. And we'll have minus 15,000. Now we want to factor this completely. One thing we can definitely do is factor out a 2, and then we can use product sum factoring to get here Q multiplied, or Q minus 100 and Q plus 75. So this gives us again two different values of Q. One is negative and the other is positive. So we're going to disregard the negative value of Q and end up getting that our equilibrium quantity is in fact positive 100 units. Now that we have our equilibrium quantity though, what do we need to find? We need to find the equilibrium price. So let's go and do that. Let's find the equilibrium price using Q naught as 100. We can choose to use either the demand curve or the supply curve because they'll be equal at that equilibrium quantity. Let's use the demand curve because it's just a little bit easier. So here we have our demand curve is 12,000 minus Q squared. So what's going to be the price when the quantity is 100? We get 12,000 minus 100 squared. And this is going to actually give us just $2,000. That is our equilibrium price. So perfect. We have equilibrium price. We have equilibrium quantity. Now we can set up our integral that represents producer surplus. Let's set up the integral. So we have here producer surplus will be the integral from 0 up until the equilibrium quantity, which is 100. We're going to be looking at the area underneath our equilibrium price, and it's going to be the area above our supply curve. So let's plug everything in. 0 to 100, 2,000 minus supply, and supply is going to be Q squared minus 50Q minus 3,000, and we're integrating with respect to Q. So now we can integrate everything. 2,000 here minus 3,000 is going to give us 5,000, and when I integrate that, I'm going to end up with 5,000 Q. Then I have minus 1/3 Q to the power of 3, and we have plus 500 over 2, which is going to be 25 q squared. And all of this we would like to evaluate from 0 up until 100. So let's plug everything in, see what we get. We have 5,000 multiplied by 100 minus 1/3 times 100 to the power of 3 plus 25 times 100 squared. And then again, when I take q equal to 0 and I plug that in, all of these terms are going to be 0. So really I'm just subtracting 0 at the end here. That doesn't matter. And what we end up getting is going to be approximately $416,000, 666.67. And that is going to be our producer's surplus.